Okay, so does everything line up? There are the two basic questions. Does everything line up? And are we missing anything? And again, so this is a point to kind of sync up with each other and find out if we're working on the right thing. So go ahead to the next one. So because of Project Sharp, which relates to Project Treble, we actually are doing some kernel functional testing. And these are the boards, and I actually don't remember the specific color coding. I don't know if you know, Mike.
Yeah, the black ones, the boards exist.
Okay.
Or in the system, and the other, or whatever color that is, the candidates, that's the bottom.
Yeah.
Okay, so the black ones are the ones that are in and theoretically running. The other ones are in progress of coming on board, and they're not.
Are we already testing XFG?
Yeah, that seems.
It shows up in the dashboard.
Okay.
Tom will probably talk to it better than this.
Yeah. Can you talk to the list of LKFT boards?
Sure.
Planned and yeah.
Sure, planned and
Here, I'm going to give you
multi-spectral colors and
yeah. There you go.
All right. Hey, everybody. So this slide's just kind of meant to be a bit of a status, not where we are today, as well as kind of where we're going as far as boards are concerned that are in LKFT/Project Sharp. So what we're using when we're testing kernels. So when you get into this, I guess, kind of red color or whatever here, that's boards which are not necessarily in and are not being something used for testing a kernel today. We do have 410C boards in the lab. They're plugged in, but we're still kind of validating them and kind of working the kinks out yet. So really our workhorse boards right now are High-Key and x86-64. X15 is so close, almost there. So that's kind of why I went ahead and put that one black, because I was being optimistic that it's going to be a good week this week. We're going to get lots of stuff done, and so that was going to make it kind of the last mile. Not quite very late. So within kind of the Project Sharp LKFT universe, this is not sort of priority order. It's just an alphabetical order. We need to kind of work with the members yet and kind of get a reading at a steering committee level, at least as far as what they think should be higher or lower priority. Then as far as kernels are concerned, what we're actually testing in LKFT and spending cycles against. So mainline, next, current stable, LTS 4.4, 4.9, 4.14 we're already looking at. So when RC1 hit the blocks, we were already checking to see what that one was like. We're actually pleasantly surprised because the Linaro case-out test was actually executing. So yay, bugs died. And then Android Common, so there's a number of trees that are in the Android Common Git tree if you pay attention to that. So there's now like -O release and -O and -N and all that kind of good stuff. So that's all on our radar screen. We're trying to figure out exactly how we want to make that all work, and so that's a discussion that kind of be had. But I think what's important to understand as far as Android Common is concerned is it's really great that Google has gone into a mode where they're aggressively picking up LTSs when they're released. So the Android Common kernel will pick up those patches. They of course have their auto treat Android patches, and they're tracking 4.4 and 4.9, and doing a really great job on that. So that's what's here.
So what about? Well, this is specific to LNG related work, right?
Yeah, but the thing is I think what's cool. Okay, what's really cool about this is it doesn't have to be specific about LNG. This is just a representative of the hardware that we started with. I mean, putting in ARM server hardware, that's not that's not out of the realm of the possibility here. Likewise, the kernels that perhaps the networking group cares about, or take the LSK, you can get that into the system. So there's a lot of room for commonality of interest. And a key element in all of this, yes, we're trying to do kernel tests, but we want to make sure that the kernel engineers, not only in this room, but in the great wider world, even outside of the Linaro conference, they'll be interested in this too. We want to show them what we're doing, make sure that it does things that are interesting to them so that they kind of engage in all of it as well.
And I saw Ryan here, if he's still here, I'll put him on the spot. There you are. So we should talk about the purposes of LKFT, Linux kernel functional test. It certainly relates to the work going on with Project Sharp, but it isn't only targeted for that. So this wasn't really meant to be a Sharp update, but it might be worth quickly talking through where we're at with kernel functional test and what actual testing we're doing.
Tom looks like he's going to have some slides or something.
I might be angling for
I'll
that.
give you.
Go ahead.
You hold that, and I'll hold this. Give it to Tom.
Sure. So the current progress, or let's just start with the vision. So the vision is, I was asked by Mark to put together a framework that could be used for functional testing throughout the company for all stakeholders. So that's quite ambitious. And of course, you have to start with one place. Starting point has been Sharp, just because most of our members align behind the goals of Project Sharp to start with. And it was a good use case, and we had a lot of investment as far as member and stakeholder interest. So that's where we started. That largely covers Android common kernel testing to begin with, but then the focus shifted to functional testing of the LTS trees, 4.4 and 4.9 specifically, and now 4.14 RC. Now, as far as how successful have we been in that testing, we're well engaged now with Greg Crow-Hartman. He's basically polishing and commenting on what we were doing, getting into a place where he likes it. His goal and our goal is that we start reporting in his stable mailing list whenever he pushes commits to his trees, to his stable trees. But like I said, this is just the first goal. So I think we're getting close to what Greg's looking for in LTS. We're going to start sort of extending our reach into other kernels. So for instance, we have an objective at the end of this month to start testing LSK on a per push basis. We're also looking at helping the enterprise group with their RPK and testing their RPK. So we're already sort of doing some of this. We just want to get to a per commit cadence. So that's ultimately our goal. We do have a long-term vision as well, which is to help our members. When they have a new board, what we want to be able to do is help them do per commit level testing on their proprietary boards within their own labs. That's sort of one of our stretch goals over the next year. So, Tom, did you?
Why not we show them some real data?
Yeah. You want to walk them through this?
Okay. So there's a couple ways of taking a look at LKFT. What this is a QA-report.linaro.org. This is all public. You don't need to log in. You just go there and here's the data. It's organized, and we're still kind of struggling with this a little bit, but I think we're getting closer at dialing it in where it needs to be. So it's project out on the outside, so LKFT for Linux functional kernel test. And then what we're trying to do is have the tree that's in use, and then kernel version, of course, and then lastly end up with what's the user space that you're using to run the tests in. So really that's just open embedded or Android. So just kind of scrolling through here. So like, let's take a look at mainline. Okay. So this is literally mainline. Based on when RC2 dropped. Go in here. Come on, go to it. There we go. So usual set of boilerplate information of what were you running, where'd you get it from, what Git repos were involved, what was the version of the tests that were involved. So that's kind of the middle stuff here, like kself test was the URL to the exact set of tests that were used, like huge TLDFS, same thing. So on and so forth. So you make it all the way through so that you, as somebody looking at this data, if you want to replicate this, you've got enough information where you can go and do that. Okay, as far as the actual data itself, now it starts to subdivide based on the architecture. So you notice like right here, there's high key. If I keep scrolling down, like here's x86 results. Okay, let's pick on like say K self-test here, which has got some fails. I don't want to preview it, I want the real thing. There we go. And so now we're walking through and seeing the individual test case and pass, fail, all that kind of good stuff. Now, going even deeper, we want to start seeing console output and the runs themselves. That information is around too. So that's all something that you can dive into as well. So it's again, we're trying to be. This is all about empowerment and making things easy to detect a regression and be able to hop on that regression and get to do something about it.
So there are two things that are actively being worked on that will make this a lot easier than it is today. One thing is that drilling down into the next step is currently a lot harder than it should be. The other thing is we want the default output to be all green. Right now we still have a number of red items where things are known to fail, and we need to keep working at them one at a time and make sure they all succeed by default, or we stop trying them if they're hopeless.
Likewise, what we do is there's a certain amount of triage. So like Arnd and Smeet and Emmett Winder and Steve Muckle, we're working a bug list. And so if you pop into bugs.linaro.org, there's a Linux kernel functional test family that's there. You do a query on that, pick on an average bug, and we're keeping it running. Here's what's going on. Here's how this has been debugged. Here we've approached such and such kernel maintainer. Here's the discussion on the list that's going on. So the whole idea is that we don't want to let this stuff sit. We want to keep things moving along. So.
Did you want to show the LTS dev archive, just as far as what we're doing from the reporting perspective for maintainers?
Yeah, are you thinking of the list archive itself?
Yeah, if you have quick access to that.
I guess I'll have to pull it up again. I forget the URL.
Yeah, I can try to find it.
List of the log?
Yeah, it should be as
And then you can just click through from there.
Yeah, you can.
So I got a question while you're looking.
Yeah, go for it.
What's the cycle time to run these tests? Because you said you want to do it.
You said you want to do it at check-in.
Yes.
So
So
what's
it's
the cycle time?
It's per push, and we're looking at, we're running a poll, about 5-minute poll on the trigger. So I think I was speaking with Greg about 3 or 4 weeks ago, and at the beginning of the meeting, he asked, when are we going to get results on the test? He just pushed 10 minutes prior. And I think within 45 minutes, we had results. We had full run results. So we're looking at about an hour after push.
One thing we got to mention here. Okay, here's a real good example of why you want your support upstream for a kernel. So I'm now up on the soapbox, so please bear with me for a moment. So like, when it comes to like the 4.4 LTS kernel, we do part of the validation for that kernel on high key. Well, not all the high key support is upstream for 4.4. Well, what happens is when 4.4 RC gets released out onto the list, we have this little, should be automated step to go ahead and rebase our platform support that was out of tree on top of what's going on out in the outer world with this new RC release. Guess what? It doesn't always work. So that means manual intervention is required. Well, what happens when the RC gets released at 2 in the morning? That's awesome, isn't it? So that starts introducing lag. So if it takes you a couple of days to rebase a set of patches manually, go ahead and retest that, get some sort of meaningful test results, that is a royal pain in the butt. We do not want that. So for those boards to be most effective in this environment, your kernel support needs to be upstream.
And one more thing to add, we do it for high key, because that's one of the 3 boards that we start out with. We're not going to do it for another board.
Exactly.
So I do work for Fedora. I'm just curious, when you run into conflicts when you're rebasing your stable series, what do you typically run into conflicts with?
It's usually been high key. Yeah, so far we haven't seen any conflicts with a high key tree with the stable RC yet.
So sometimes we've had cases where
as code's gone upstream for Hyatt, it's gone through revisions, and then some stuff gets tagged as fixes, but then gets backported to the older kernels, which had an alternate solution, or an older solution, basically. And so now we've got kind of this thing that we have to munge and figure out what the right answer is to make it go. So those sorts of things have happened a couple times.
All right, Tom, you want to scroll down? You should probably go to the bottom of September here, because it's probably the most recent. So let's look at one of the. Let's see, yeah.
There we go. There's
Yeah, let's look at one of the no regressions found. Let's go with the previous one actually. The Android ones are a little bit special. So if we look at the 4.4 so this was rebased on. This was triggered basically on Sumit's update following Greg's pushes. I don't recall when Greg did it. It was within the last few days. So this report format is pretty much what Greg's asking for. It is up for debate. As soon as we start sending these in an automated fashion to Greg's mailing list, we're just waiting for his approval, then I suspect other maintainers will pipe in with their pleasure or displeasure. But the objective of this is to give the kernel engineers as little information as necessary in order to determine whether we have found regressions with that push. And then we also, of course, give the detailed report. And also, when there's no regressions, we're actually identifying, hey, there's no regressions. And no regressions on what particular hardware.
Yeah, let's see if we can find one with regressions.
Yeah, so the regressions ones are a bit earlier. The last few RCs have been pretty good. Yeah, so that's actually a comment. So if you go look at that thread view, it will be a little easier.
So, sorry, where we're looking at that. So right now, the amount of kernel functional test is limited, right? Because we're trying to get the process to work reliably, get the output in a way that Greg and other maintainers will accept and find useful.
Yeah.
What's the process for when we're going to add new additional tests, and who decides that?
So as Arnd was saying, the objective is get those all green, get the baseline. And getting a green baseline has been a bit difficult. We've had to resolve def config issues, resolve environmental issues, resolve hardware issues, and then there are still some lingering kernel problems. So I think we're going to try to get to green as well as we can in K-self-test. We're engaging with K-self-test maintainers and subsystem maintainers right now about how to add tests to K-self-test, how to test them, how to make sure that the version we're running corresponds with the software we're testing. So that's an ongoing discussion. As far as other test suites, we've already started executing LTP syscall tests, and we're actively working with Steve right now, I believe. These are up here somewhere, I think. We're working with Steve to look at a subset of LTP that we should be executing and slowly adding it in. So our intention is add a green baseline, add to the green baseline. Don't just drop in a huge test suite and start reporting failures like crazy. So we're kind of approaching this from several different angles. As far as new tests, we do have some new tests that we do want to look at. I think Tom can tell you what those are off the top of his head.
Well, not off the top of my head, but yeah, it's on a slide. It's on my.
We're going to look at LKP, I think.
Yeah, LKP. We want to talk to the 0-day guys. We want to talk to what was it? XFS test.
XFS test. That's the next one on the list. Yeah.
Oh boy, what was some of the other ones?
There was MM tests.
Yeah, MM tests. That was another one.
Yeah, the point is go from green baseline and keep it green as we add more tests.
And this is an important area too for member input. Not only what are the important test buckets, but if you've got any of your own test buckets that you'd like to contribute to this, we're really interested in that. The better we can make this system, the more it helps all of us.
So K-self-test is sort of an interesting target because traditionally it's been tied to the kernel that it is a part of. What we are trying to do is to run the latest K-self-tests against LTS kernels, and some of the reds that we see today are because They don't function very well. So most of the problems that we had where we could identify the feature that is missing, we were able to push patches to skip them on older kernels. But we still have issues with a few subsystems where the tests are very closely intertwined with the thing they're trying to test. And in those cases, we don't really have a clear answer. In some cases, the subsystem maintainers are helpful and see that what we're trying to do is useful. In others, not so much. So one thing that we, I think, wanted to talk about is if there are any subsystem maintainers here, do you have any views on should we continue testing like that? Because LTP and other tests are easier because they're not tied to the kernel that you're trying to test. And
LTP uses the kernel version check thing, right? So
Just the version check.
So you're supposed to write tests based on, and the library allows you to check for the kernel version. So based on that,
you really shouldn't be using a kernel version check if you're interested in testing people's stable kernels, because that ends up not working.
Oh yeah, no, I was just saying the fact that LTP is
Does
easier
that,
because it does kernel version.
So far, yes.
So far.
But yeah, I mean, probably we would like to ask if, subsystem maintainers who are at Linaro, who are not at Linaro, to try and help in that, trying to at least write new tests that will adhere to that. So when we move to 4.15 testing, 4.14,
As a regulator maintainer, how good's the fire suppression system in the lab?
all right. Is that because you're
I can make boards catch fire.
Please don't.
That's what I was asking.
You're demo Friday.
Tom?
One thing I noticed that there's already still some failures still to be resolved, and but even before folks go on to looking at new tests, folks considered debug configs for the kernels. So going through and enabling lock depths and all the memory debugging and all of that inside of the kernels. In order to, I mean, to some extent, it's finding more problems. You won't expect the test to fail, but you'll get demessage junk.
I think that's a very good point that we've never really discussed. That we should definitely do that.
The locked ones get fun because they start breaking boot because of rubbish bootloader issues. But yeah, that's a good idea. We're finding a bunch of useful stuff with that in kernel CI, just from the boots covering stuff in boot test. We do have to turn off the locked stuff, and it's also more and more if you're running on stable kernels, it's more and more difficult to convince people that they actually care about your locked splat in an old kernel or your KSAN splat or whatever splat it happens to be in an older kernel than a new one. So that sort of stuff could always only be turned on for mainline and next, though, which would help maintain people's interest.
Yeah, that sounds good. Because it's one of those, you can get those combinatorial explosions.
Yeah,
it's as well. And so it's one of those things where I don't want to cause a lot more work, but the idea of at least getting some checking.
I mean, the set we've enabled for kernel CI is fairly, the overhead's fairly low, apart from the fact that especially locked causes the kernel size to bloat, which causes boot failures because of overwriting the DTB and things like that. So that gets annoying, but otherwise.
Some of them are really expensive, like slab debugger.
Yeah, but it slows down the runtime, but it's not, in the grand scheme of things, it works out not that bad.
You want to go ahead and talk about
Right. Are we done with the LKFT? Any more?
Well, a similar question, what about like some of the unit tests within the kernel? Like DT has unit tests that can be enabled.
Get them enabled in case of test.
No, the boot time tests.
Or the boot time?
So repeat the question.
Yeah.
So there's tests that typically run on boot that are unit tests within the kernel. So
the DT API within the kernel has tests. There's things like, I think there's some performance tests of like crypto algorithms.
Yeah, some of the trace stuff, trace has a big boot time test suite as well.
And then there's, is it like the RCU torture tests?
Yeah.
So I really think we should find a way to integrate it into K-self-test in some form, even if there's just one K-self-test that outputs the data again in the same format as the other K-self-tests. So we can probably come up with some solution here, just to have it not be another test suite. But we should be running those tests, yes. And it's probably the same as the debug kernel, that like we would have to enable all those options. We could enable it at the same time as the runtime debugging. So if there's nothing else about LKFT, I can talk for a few minutes about the common kernel work that we've been doing since the start of Linaro. The main goal we've basically completed maybe a year ago, when we had all ARMv6 and ARMv7 platforms in the kernel in a state where you can build them into one kernel that runs on all platforms. So that part is good.
A year and a half, at least, maybe 2 by now.
Maybe 2 years already. Yes, it's been a while. Yeah. There are still some areas that are missing. So on ARMv5, we have maybe 2/3 of the platforms. There's maybe 10 platforms left that we could still convert. This work is going on slowly. Sometimes sometimes I convert one more platform. It's not really urgent. For the modern architectures, v6, v7, v8, so in the 32-bit kernel, we actually support only 2 levels. We support v6 and v7, and I keep thinking we should extend that and formally have v7, VE, and v8 as separate levels, maybe also v8.1, v8.2, because while most people run a 64-bit kernel on v8, some people do not. Like Raspberry Pi is a popular platform where people do run a 32-bit kernel, but we don't officially support that at all. Like the kernel doesn't have a config ARMv8 option, and certain things are different. We should probably treat them that way. We also don't have an ARMv6 dev config, so for all the slightly older platforms, we don't have a single kernel that we don't provide a configuration that runs on all of them, even though we could. The question is whether anybody cares. For the ARMv7 VE, it would make sense because it's much more efficient to have the integer divide instructions, and it would also be a good way to determine whether we should have virtualization support or not, because that's the basic same architecture. And also LPAE. So we do allow LPAE on all ARMv7 platforms, even though most of them, the older ones, don't support LPAE. So any questions or ideas about this? And on ARM64, of course, there's no problem at all. Everything runs in one kernel. Okay. So next.
So back to let's talk about the RPK a bit and what that's used for. So.
Yeah, so the RPK is, well, it was when we have more reference platforms, it was maybe going to be more widely used. But right now, it's basically only used by the enterprise reference platform. It's the kernel they ship. It contains, or it's a current-ish kernel from Linus. The current one's based on 4.14 that they're gearing up for using in their next release, which is coming in a few months. I can't remember exactly when.
3 times a year. Sorry.
Yeah, I just don't know which times.
Yeah, I don't know either, but it's roughly 3 times a year. We just did one recently, I think.
Yeah, and they're gearing up for the new one. It contains it's the current version of Linus's tree, and it also contains any patches that people feel are important to backport. And essentially the only rules for that are that it's got to not break things for other people, and it's got to be something that's being actively discussed upstream. So it doesn't need to be actually upstream, like we require for the LSK. It just needs to be something that somebody's posted to the list and is being talked about upstream, even if the conclusion upstream was that it needs to be revised. And that's been used for the past 2 enterprise reference platform releases. There were a few bumps with the first time it was used, but the recent release that went out last month, everything went very smoothly, and we were now seeing nobody's actually asking for backports right now, which I think is a sign that the requirement to push everything towards upstream has had the desired result, and platforms are now well supported upstream, and hopefully don't need too many backports. There might be some if there's some new hardware, but other than that, we're not anticipating anything.
So, not to switch gears, because we can stay on RPK, which that's released in the ERP. So,
yeah. So the RPK itself doesn't actually release. It's just a git tree, and then people who want to use a kernel in their their bigger software release, their distribution, pick it up and do release management on it themselves.
Right. So you mentioned LSK. So what's the current state of LSK, and any changes there recently?
LSK is running along fairly smoothly. The big change, it's not so recent anymore, it happened before Budapest, is that following the discussions around Project Treble, we're not going to be doing new Android LSK releases. Instead, we're going to be trying to contribute things that would have gone into the LSK to the Android common kernel. Now that's a bit more open to features. So that process is still a work in progress, but hopefully that's going to go well. So we're still maintaining the regular LSK and the RT version of the LSK for users who aren't using Android. The current version that's in active development is 4.9. We also have 4.4 still in maintenance. And yeah, if anybody has any feature requests, then speak to myself or Alex Shee, who's the main maintainer of that, and we'll talk about it.
And you can also submit those requests to the mailing list?
Yeah, we via email or the mailing list, or talk to us in person, or any way you can get in touch with us, we'll try and work with you.
So basically, within Linaro, other than working in mainline kernels directly for the work that we do in a lot of the groups, we have these fundamentally 2 kernels that we work with, right? RPK and LSK.
Right. Yeah, and like I was saying, with the RPK, people seem to have been doing well enough at upstreaming that it's actually somewhat losing its relevance, which is wonderful.
Yeah. And then back to testing for a minute. The ability for LKFT to add kernels in the future, add tests, is something we're striving for to help that whole ecosystem work. And there's also the kernel CI project, which is also a testing feature, but it's build and boot testing versus LKFT is actually functional testing.
Right, yeah, currently there is some community interest in testing in kernel CI, but we're not actively working on it.
Right.
And kernel CI, the other big difference is kernel CI is focused on broad board coverage, whereas LKFT is really restricted in the set of boards it covers. So, but that means it's also got more bandwidth on those boards to run tests. It's got, I can't remember how many high keys it's got at the minute, I think it's about 20 or something, whereas kernel CI might have 1 or 2 boards of a given type.
But then it has 100 boards.
Right, it's 100 different, but it does mean you can run way more tests on if you've got a huge lab full of boards, whereas kernel CI would because it's only got one or two boards, it will be struggling for bandwidth on those boards to run a wide set of tests, unless the lab situation changes dramatically.
And part of where we'd like to go, especially with part of where we'd like to go, especially with LKFT, is we do want to work with the kernel CI guys. I mean, this isn't just this is where we're at today. Yeah, we've got two systems, but I mean, it does make sense that not only coordinating and seeing how much of what we're doing in LKFT could also be passed down into that system would be great.
There's another slide. Don't know if this is relevant or if we can do it.
So yes, this slide from Martin's just covering the sort of release process they use to make the ERP, which is, in the context of the kernel, really all it's saying here is that we, when they're making the ERP, they grab the kernel, they package it for the ERP, and then they've got a bunch of automated testing around the enterprise reference platform, which obviously ends up providing some coverage to the kernel as part of the distribution-wide testing. So that they've got, it's called the Linaro Enterprise Test Suite. I'm not 100% sure what's actually in it because the enterprise people handle all the actual working with the test suite.
Is anybody here from that team can cover that?
I'm covering for them.
Okay. Well, there you go.
I do maintain their kernel for them, so it's
so basically, it's open to questions from you all. One thing we want to do is try to clarify what kernels we're currently working with within the Linaro context, and what we're trying to do to validate those kernels. And the question is there other needs? Is there other things that we're missing that people know about that we should hear about? So this is an opportunity for you guys to tell us, give us any feedback.
I think somebody in this conversation went around a bit, but try building like a lot of the drivers you guys are using as modules, because try building a lot of those kernel drivers as modules, because there's dependency problems in some of them and just assorted things.
What kind of dependency problems?
Like design where stuff doesn't get put into, did our keys properly with rack cut and things like that. So, and previously,
So one thing that I'm doing by myself is to build test an incredible number of kernels. Like I built for x86, ARM, and ARM64 at the moment. Several thousand, well, around 1,000 kernels per day, and I try to work on all the dependency issues and all the other build time issues we see while build testing, which catches a lot of things, but it doesn't catch
it's a runtime. Basically, you can build it, you just can't load it.
So kernel CI does boot testing for a bunch of modular configs, including all mod config. So something's working. Obviously, all mod config you can't test on every board because the binary ends up rather large.
I don't think we can actually run in all mod config.
We don't. You're right. We don't run it. We do run some of the other ones which do have mod stuff turned on.
Yes. So we at some point a few years ago we tested what it would take to get all mod config actually booting on a number of hardware. We came around a dozen options that we have to flip in the kernel. Like all mod config would be a big endian kernel, for example, and also the user space that we have is little endian. So flip that, and then the serial port driver for the console. If you build it as a module, you don't have any console output, which is limiting.
Well, you do eventually, but.
Other feedback or questions?
The CPU ID information. There is a file node in block CPU info. On the ARM platform, it's a lack of
we can't get many detailed information about the CPU. This is a known issue for years, I think. I just wonder why it isn't fixed for so long time. And do we have any plan to fix it?
So two things about this. Changing the proxy CPU interface is always hard because we never know what might break. It's a complex form.
I think we don't change the interface because there is such interface on x86. Many applications depend on this interface.
Right.
For example, OpenStack and so many.
And that's why you don't want to change it too much. The other thing is the SOC info. So we have in SysFS for many SoCs, you can look into sys devices SoC or sys bus SoC. And there's a couple of standardized properties you can look at in the SysFS format. So they're fairly standardized what you can put in there. There's some of them are less clear than others, and we can add additional fields if needed.
For many applications, we just want the applications run on ARM as same as on x86. So we don't want to change the application code. We just want to the both platform. So.
But most of the fields that are on x86 in that file don't make any sense on ARM.
And if we put things in there, we would need to change the application code to parse the whatever we added in there. So.
Could you give an example of what field you're missing?
The question is from my colleague, so I don't know the detail, but I know this issue is for a long time. Mac is here. In LNG there was a card to fix it, but without a result, I think. So I think in Linaro we should collaborate to fix such issue because we are building the software ecosystem. So I think somebody or some group should take the responsibility.
I still don't understand what was missing.
There's some, if I remember correctly, for 32-bit ARM, there's some differences like in CPU info versus x86, and that makes LS hardware not work right for getting important things like modem maps.
Yeah, LS hardware doesn't work.
But it's a user space application. And
yeah, the CPU info part also affected 32-bit Android apps, for example, but I think there's a patch in kernel which basically figures out if the personality is Linux 32-bit, it basically shows up as ARM v7L or ARM v8L for 32-bit apps running on 64-bit kernels. And that patch I think is upstream. So Bionic, if you have a 32-bit app will set that personality before reading proc CPU, or basically when the app starts. So if the app reads proc CPU info, it will show up as a 32-bit CPU.
So we could add another personality where we pretend we're an x86 machine and then have the format as an x86. So that an application that you port from x86, you just set the personality and then reads the file. Would that help you? I mean, if we already have the code to make a different format based on personality.
We do. I'm just wondering what we put in there and whether something would get very, very upset about the
Could be just static information, could just be like hard-coded, whatever, every time the same thing as long as you want. If you only want the x86 format but don't care about the contents.
I'm worried that if they're looking and they care that much, they do care about the contents, and they might get upset about the foul lies we just told them. Like if they're doing, like I know things do try and parse that to enable optimized assembly code and things like that.
Yeah.
Which would not end well if they actually managed to build.
Is it easier solved with some specific cases?
Yes.
Other questions, comments? Okay, thank you everyone for coming.
Thanks, everyone.